Alright, so we're going to go ahead and solve this one. Okay. Now this one, your first step is actually necessary because you can factor that x squared plus 7x plus 12. Okay, so your first step, you're going to factor. Okay, so I'll put that on the side and we'll do that factoring over here. So x squared plus 7x plus 12. Remember, you have to find two numbers that multiply to equal 12, and they add together to equal your b, which is 7. So that's 4 and 3. We had one similar to that earlier, but it was negative. So we have 4 times 3 and 4 times 3. So this factors into x plus 4 and x plus 3. Okay, so we can actually factor this one. So the 3 and the x plus 3, they're as factored as they're going to get. So we have 3 over x plus 3 equals, you can't factor anything out of this numerator, so that stays the same. So you have 12x plus 19. And this one we just factored over here. So you have x plus 4, x plus 3, minus 5 and x plus 4. There's factored as they're going to get. So 5 over x plus 4. Okay, so step 1 is out the way. Everything's factored out. Okay, so step 2 is we're going to match all of our denominators. Okay, so if we have our 3 over x, I'll give it a little bit of space, equals 12x plus 19 all over x plus 4 times x plus 3 minus 5 over x plus 4. Okay, so really you can match these up by multiplying this one times x plus 4 over x plus 4 and this one times x plus 3 over x plus 3. That's the only thing, you just want them to match. You don't have to do anything really, really horrible to them. You have x4 and x3 here, and you want those two to be the same. Okay, so if we multiply this one by x plus 4 over x plus 4, and we multiply this one by x plus 3 over x plus 3, now we have our matching denominators. X plus 4, x plus 3, x plus 4, x plus 3, x plus 4, x plus 3. Okay, so everything's nice and evened out. Okay, so that gives us 3 times x plus 4 over x plus 4 times x plus 3. Equals 12x plus 19. We didn't have to multiply that by anything, so we're good there. Over x plus 4 times x plus 3. Minus 5 times x plus 3. Move that up a little bit. Over x plus 4 times x plus 3. So remember the previous examples where if the denominators are the same on both sides, if you multiply each side by that, the denominators would disappear. That's why I told you if you wanted to, you could skip that step because problems like this would be really long to rewrite that canceling step. So once they all match up, you can just get rid of them because they're going to cancel out if you multiply each term by the same one. Okay. Okay, so multiplying each term by, make sure I move that up a little bit, x plus 4 times x plus 3 cause them to cancel out. Okay, so that leaves you with just your denominators. Okay, so you have 3 times x plus 4 equals 12x. Uh-oh, forgot my x. 12x plus 19 minus 5x, well, times 5x plus 3. Make that a little bit neater. There we go. Okay, so that's why that step, you pretty much want to know you can skip that multiplying step if you wanted to. If you had to write x plus 4 times x plus 3 over 1, x plus 4 times x plus 3 over 1, x plus 4 times x plus 3 over 1, and didn't do all the canceling, that's an extra couple of minutes you really don't have to do. All right, so any questions on this so far? All right. Okay, so now we just go ahead and we get rid of all of our parentheses and combine like terms and solve for x. Okay, so if we go ahead and we distribute our 3 here, we get 3 times x is 3x. Oh, move that up a little bit. And 3 times positive 4 is positive 12 equals 12x plus 19. If we go ahead and distribute that negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. So you go ahead and combine our like terms. We can combine, I'll do the right side first since we have a few we can combine there. Uh-oh. Okay, so 12x minus 5x will give us, probably shouldn't put an equal there, the arrow. There we go. So you have 7x here. And 19 minus 15 is 4. And this side we didn't do anything to yet. Okay, so if we subtract 3, or you can subtract 7x on both sides if you want to, but you don't have to. So if you subtract 3x from both sides, 3x minus 3x is 0, so that disappears. So we have 12 equals 7x minus 3x is 4x minus 4. Scoot that up a little more. Okay, so if we add 4 to both sides, those cancel out.
Professor?
Yes.
Wouldn't that be a positive 4? 19, 15, negative 15.
Oh, did I write? I did write negative 4. Thank you. I don't know why I put negative there. Oops, that should be positive 4 and negative 4 here. There we go. All right, so if you subtract 4 from both sides, you end up with 12 minus 4 is 8 equals 4x. And divide both sides by 4. You have x equals 2. Okay, but you still have your fourth step, which is you have to check it. Okay, so if you have, I'll just rewrite it instead of scrolling back down. 3 over x plus 3 equals 12x plus 19 over x squared plus 7x plus 12 minus 5 over x plus 4. We notice plugging in x equals 2 will not give any denominators a 0. So you're actually okay there. Is a solution since it will not cause a denominator of 0. All right, so any questions on this one? Okay. Now the next example will have one that will cause a denominator of 0, so I'll show you how that one will look. All right, I'm still writing. All right. Okay, so let's say if we wanted to solve, where's that? 1 over x plus 2 equals 4 over x squared minus 4 minus 1 over x minus 2. All right, so the first step, is we're going to factor. Okay. So we know this is a difference of squares, so we'll factor that on the side here. So we have, don't really need parentheses just yet, x squared minus 4. There's a difference of squares. You can rewrite that as x squared minus 2 squared. So that would just factor into x plus 2, x minus 2. Okay, so if we go ahead and factor these out, our 1 over x plus 2 stays the same. That's as factored as it's going to get. Equals 4. You can make that 2 times 2 if you want, but you don't have to. We can just leave that as 4. And x squared minus 4 is x plus 2x minus 2. Minus 1 over x minus 2 is already factored, so nothing to do there. Okay. So now your second step is you want all your denominators to match. So you're going to match your denominators. Okay, so if you see here, you have 1 over x plus 2 equals 4 over x plus 2, x minus 2, minus 1 over x minus 2. This one has x plus 2 and x minus 2. This one will match if we multiply by x minus 2, and this one will match if we multiply by x plus 2. Okay, so we multiply this one by x minus 2 over x minus 2. We multiply this one by x plus 2 over x plus 2. Oops. Here we go. Okay, so now we have all of our denominators match. X plus 2x minus 2, x plus 2x minus 2, x plus 2x minus 2. Okay, so if we keep on going, you have 1 times x minus 2, which you don't have to write the 1 if you don't want to, but we're going to do that anyway, over x minus 2x plus 2. Equals, this is already x plus 2x minus 2, so we don't have to do anything there, minus 1 times x plus 2 over x minus 2x plus 2. Okay. So when all the denominators match, remember before, they all cancel each other out. So multiply each term. Clean that up a little. by x plus 2, x minus 2. We'll cancel the denominators out. Okay, so once they all cancel out, you're left with 1 times x minus 2 equals 4 minus 1 times x plus 2. Okay. Now for our third step, we just get rid of all the parentheses and we solve for our x's. Alright, so if we distribute the 1 here and we distribute negative 1 there, 1 times x is just x. 1 times negative 2 is negative 2 equals, you just have 4 there, so that just drops down. Negative 1 times x is minus x. Negative 1 times 2 minus 2. Okay. So if we go ahead and simplify it, we can actually combine those two. Okay, so we end up with x minus 2, bring that up some. X minus 2 equals 4 minus 2 is 2 minus x. Okay, so if we add x to both sides, minus x plus x, that cancels out and disappears. So we have 2x minus 2 equals 2. So now if we add 2 to both sides, minus 2 plus 2 is 0, so that disappears. So we have 2x equals 2 times, well, 2 plus 2 rather is 4. And if we divide both sides by 2, oops, sorry about that. Anything divided by itself is just 1. Move that up a little bit more. So you have x equals 4 divided by 2, which is 2. Okay, and now from here, go ahead and do our check. Okay, so I'm just going to rewrite the expression 1 over x plus 2 equals 4 over x squared minus 4 minus 1 over x minus 2. Now, if you have x equals 2, it doesn't have to do it for all of them. If it makes one 0 denominator, you can't use it. So if we plug it in here, and actually if we plug it in here also, it would make a 0 denominator. So actually this one doesn't have a solution. Since x equals 2 will cause a denominator of 0, it is not a solution. Okay, so in this case your answer will be no solution. All right, so any questions on that one?
So if that's not a solution, it'll just be no solutions at all?
Yep, just no solution. All right, so I'm going to try to squeeze in one last one, and this one will be quick. Oh, anyone still writing? Okay. Okay, so let's say, for example, if we wanted to solve, say, x plus 14 over x minus 2 equals 7x over x minus 2 plus 1. Okay, so this one you don't have to factor because You can make that 7 times 2 if you want, but you don't have to. So first step, no factoring necessary. Okay. Now your second step, remember you want to match all of your denominators. Okay. So to do that, it's pretty straightforward when you have just x and 1. Because for here, I'll make a little note here. X, you can make that equal x times x minus 2 over x minus 2. And 1, you can make that equal x minus 2 over x minus 2. Okay, so you can rewrite both of those just single terms as a denominator, because this way it makes both of those have your same denominator. Okay, so that gets us from x to x times x minus 2 over x minus 2, because if you cancel both of those out, you end up with just x. Plus 14 over x minus 2 equals 7x over x minus 2 plus x minus 2 over x minus 2. Okay, so all of your denominators match. Remember, when they all match, both sides of the equal sign, they just cancel out. So multiply each term by x minus 2 to cancel denominators. All right. So that means if all of those eventually cancel out, we end up with x times x minus 2 plus 14 equals 7x plus x plus 2. Okay. Now your third step is you just solve it. Oh, there we go.
On the last one, x plus 2.
Oh, hey, sorry about that. I don't know why I put x plus 2, x minus 2. Thank you. I think writing the plus sign there got in my head. All right, so here you just solve. Okay, so if you distribute that x, and here you can just distribute a 1 if you want to. So if x times x is x squared, x times negative 2 is negative 2x, plus 14 equals 7x, and 1 times x is just x, and 1 times negative 2 is negative 2, so that just simplifies there. All right, so now we just combine all of our like terms. So on this side, nothing to combine, but this one, we can just make that 8x. Okay, so we end up with some x squared minus 2x plus 14 equals 8x minus 2. Okay, so for this one, we can subtract 8x from both sides. And we can add 2 to both sides. Okay, so 8x minus 8x is 0, so that disappears. Minus 2 plus 2 is 0, so that disappears. We end up with x squared, negative 2x minus 8x is minus 10x. 14 plus 2 is 16 equals 0. And from there, we can just go ahead and factor. Okay, so we find two numbers that multiply to equal our C. And those same two numbers add to equal our B. Okay, which numbers?
-8, -2.
Yep, -8 and -2. So -8 times -2 is positive 16. -8 plus -2 is -10. Okay, so this would just become x minus 8 times x minus 2 equals 0. Okay, so we know if either one of these equals 0, then the whole thing will be true. So that means that x minus 8, can equal 0, or x minus 2 can equal 0. Okay. So here, if we add 8 to both sides, that means x can equal 8, or x can equal 2. All right, so the only thing left is our last check. Okay, so for our fourth step, we'll do our check. Okay, so we're actually going to check x equals 2 and x equal 8. So if you have x plus 14 over x minus 2 equals 7x over x minus 2 plus 1, we see automatically if we plug in x equal 2, that gives us a 0 denominator. So for x equals 2 is not a solution. Because it gives a denominator of 0. Okay, so we can cross that one right off. Now, x equal 8, if you plug 8 in, you don't get a denominator of 0, so you're good there. X equals 8 is a solution, or actually your only solution. Since it does not give a denominator of 0. Oh, move that up a little bit. All right, so any questions on that one? All right, so that's the last example. If you have any questions, feel free to hang around and ask away. If not, I will see you on Tuesday.